Hello everyone. So now we are going to move to the third derivation, that is electric field due to a dipole, an electric dipole at any point. At any random point we are going to find out. So I have given one diagram here. Let's analyze the diagram first, then we'll move to the derivation part. Okay. So now you can see that here there is a dipole here. So there is a plus q and minus q, and they are separated by a distance a and a. So total distance will be 2a. Okay, I marked over here. And then you can see that. So here this dipole is we have to find out the electric field due to this dipole at this point P. You can see the point P over there. At this is a random point. So how do we identify this random point, or what is the address of this point? So we can understand that the identity is it is making an angle theta. The line joining the center of the dipole O, you can see here O, and the point P, that makes an angle theta with the dipole, moment, because you know the dipole moment direction is in this direction. So now one more thing is that the distance from this OP, that is also given R. So two things got to be very clear. Number one, what is the identity of the point P? One is which is at a distance R from the center of the dipole, and the second thing, it makes an angle theta with the direction of dipole. So two things are fine. Now the dipole moment is given over there. Now we have to find out what are the components of this dipole along the direction of line joining as well as perpendicular to it. You can see that. So you see here this dipole is P is in this direction. You can see that. And now I can mark, look at this, these dipole, like this one will be P cos theta because it is adjacent. And what about the perpendicular component? That will be P sin theta. That also you can see that. So it is very clear that the net value, the net dipole moment P can be resolved into two. One is P cos theta and other one is P sin theta. And P cos theta is along the line joining and between center of the dipole O and P, and the second one P sin theta, which is perpendicular to it. What is the advantage? The advantage is we already learned the fact that the dipole moment, if the dipole moment is in a certain direction, we can find out the electric field along that direction, and electric field like perpendicular to that direction also you can find out. So if you have a dipole moment, so that we already done where in the previous two videos, in the previous two sections, like along axial and equatorial, where the dipole moments were parallel as well as perpendicular to the line joining. So now we are going to use the same technique here. So number one I'm going to do, so that is, you can see, so I'll be changing the color a little bit. Yeah. So number one, the electric field due to P cos theta, how much will be that? Because it which is along the line joining, so which is along the axis, so then it would be along, not along the axis of the dipole, along the axis of line joining of O and P. So we already studied that the electric field equation E is equal to 1 upon 4 pi epsilon naught S 2p cos theta divided by r cube. 2p cos theta, because how much is the dipole moment along that direction? That is p cos theta. So 2p by r cube, do you remember where the cos theta was 0? Theta was 0, not cos theta 0, my bad. Theta 0, cos theta 1. It was like that. So that is why E is equal to 1 by 4 pi epsilon 0 p by r cube. So you just imagine, instead of this, if it was like this, the axis was like this, then it was 2p cos 0 divided by r cube, that is 2p by r cube. So point number one is sorted. Now what is the direction? The direction also I want you to understand very clearly. You can see that what will be the direction, which is along the direction of dipole moment. So be very particular about it. So here I just gave E2 here, It is supposed to be E1. So I'll be giving E1. This is E1. Okay, it was looking like E2. So just be particular. This is E1. Okay. So now you look at this. It was along. You can actually compare this with along the axial line. So it is along the direction of dipole moment. So that is sorted. Now you look at this. I would be giving the direction along the direction PD, along PD, which is given there. Now the second one, the number two, that is electric field due to P sin theta, which is perpendicular actually, which is a perpendicular component. So how much is that? E is equal to, we already learned it, second video. So those who have doubt, you can check that. What is that? 1 by 4 pi epsilon naught P sin theta divided by R cube. Look at this. In which direction it would be? So we already learned that since this one is in this direction, the electric field, the dipole moment and electric field are supposed to be in the opposite direction. Those who have doubt, I'm going back there. I'm going back. Look at this. Here, electric field, dipole moment is in this direction and electric field is in the opposite direction. So I'm going back again and again and I'm going back. Yeah. So where is this? Look at this. Here dipole moment is in this direction. Electric field also in the same direction. Look at this net electric field also in the same direction. So that is why we took the directions are along these directions. So E2 will be in this direction. No doubt. Because P sin theta is in this direction. Electric field has to be in the opposite direction since it is a perpendicular to the line joining. So then I can write it is along which direction? PC, along PC. Okay. So these two, like now you look at this. Here I'm going to consider it as two electric fields. They are actually making an angle over there, right? So now you can actually find out what would be the value. It's very easy. You can find out the resultant between these two. It is very clear that they are actually making an angle. How much is the angle they are making? 90 degree. Okay, so find out the resultants. So how will you find out the resultant? The resultant E will be equal to root of E1 square plus E2 square. E1 square plus E2 square. So how much is E? E is equal to root of, how much is E1? E1 is given already there. So I would consider K into 2p cos theta divided by R cube the whole square plus so K into P sin theta divided by R cube the whole square. Because if two vectors, listen, if two vectors are at a 90 degree, so I'll be writing here, if two vectors are at an angle 90 degree, let's say this vector is A and this vector is B and this is this one 90 degree, then what is the resultant? The resultant R is equal to root of A square plus B square. Root of A square plus B square. That's it. So now the magnitude of E value, let's find out. So the magnitude of E will be equal to, E is equal to, how much is that? Yeah. So you can, whatever the things you can take outside, that would be fine. So I'm taking K by R cube, I'm taking outside. P I could take outside. So it would be KP divided by R cube into root of, look at this, this is 2 square, that is 4 cos square theta plus, what will be here? Sin square theta. So 4 cos square theta plus sin square theta. So I can write E will be equal to, look at this K, what is K? 1 by 4 pi epsilon naught P divided by R cube into root of, what is 4 cos square theta plus sin square theta? You consider one thing, 3 cos square theta, you take it here, then plus sin square theta, then one more cos square theta will be there, right? So cos square theta. So what did I do? I just made the 4 cos square theta into 3 cos square theta plus cos square theta. Then that is 4 cos square theta. But you know very well what is sine square theta plus cos square theta? 1. Yes. So E is equal to 1 upon 4 pi epsilon naught P divided by R cube into root of 3 cos square theta plus 1. So this is the equation for electric field due to a dipole at any random point. So this is the final result. So now how do we know like whether this equation is actually correct or not? How do we know that whether this equation is correct or not? We can do one thing. We can do E along axial and E along equatorial. We can check with this. How do you check that? So the magnitude of E along axial is actually this is along the axis. So if it is along the axis, what is the angle between P and E? 0 degree. So you can put theta 0. So this 1 by 4 pi epsilon 0 P divided by R cube into the root of 3 cos square theta. 3 into cos square 0, cos 0 1. 3 into 1 3. 3 plus 1 4 will be coming. So root 4 2. So I'll be removing this. This is 2p by r cube. That's true. That's true. So I'll be writing since theta is equal to 0 degree. Now you can check whether E equatorial is true or not. How much is that? So look at this 1 by 4 pi epsilon naught P cos theta P divided by R cube into root of 3 cos square theta plus 1. Cos theta is 90 degree, cos 90 is 0. So it will be root 1, that is same 1 P by R cube. So what is the explanation? Since theta is equal to 90 degree. So it is very clear that this equation works in all these cases. So any random point around the electric dipole, you can find out the electric field by using the same equation. And one more thing is that how do you get the direction of this particular electric field? So you can do one thing. You can actually find out from this diagram. You can see that you can find out tan alpha actually. So how do you get tan alpha? You can do one thing. You can just extend this. Yeah. So tan alpha is equal to E2 by E1 you can do. So I'll be writing it here. So tan alpha is equal to E2 divided by E1. So magnitude. So how much is E2 by E1? So E2 already you know that 1 by 4 pi epsilon 0 K into 2p cos theta. So that is what is E2, right? Yeah, 2, sorry, this is E1 by E2 is supposed to be. So E2 will be sin theta will be coming. K into, yes, P sin theta divided by R cube. All divided by K into, how much is that? Yeah, P cos 2p cos theta divided by R cube. All other things will get cancel each other. Tan alpha is equal to, look at this, K cancel, P got cancel, R cube got cancel. It will be 1 by 2, tan alpha will be equal to 1 by 2 tan theta. That is the correct answer. So, or alpha is equal to tan inverse of 1 by 2 tan theta. So, this is the direction also. So, you got the magnitude as well as you got the direction of electric field due to an electric dipole at any random point. So I hope you understood it clearly, and it is very easy. And if you haven't understood any single step in between, please rewatch it and try to do it yourself. That's it. Okay? Thank you.